Alrighty, this is Calculus 2. This is doing mins and maximum critical values. So we're going to be maximizing some values and maximizing some equations and doing some stuff, math, numbers, okay, symbols. And that thing right there is pi, not p. All right, so let's take a look. I identify absolute maximum minimum values and local extreme. Now, of a function, so definition absolute extrema would be, let a function be defined on interval I if there's a number u in the interval for where f of u is greater than or equal to f of x. Okay, for all x in that I, the interval, then f has to be an absolute maximum. So basically, if that's the highest point, it's the absolute maximum. Okay, at the u and the number f of u is called the absolute maximum of value of f on I on that interval that we're talking about. Okay, so we're normally referring to this in a bracket type of sense. So I have a end on both sides. So otherwise, I would be referring to a global minimum, a global maximum. So that would be like end behavior. So what is the functioning happening at the end, at both ends? Is it going up to infinity? Is it going down to infinity? Okay, those type of things. So, but on this right now, we're just talking about just bracketing. We have two, we have a left end, we have a right end. Okay, so that is including those endpoints. Okay, if there is a number v for I, which f of v is less than or equal to f of x, for all x in that interval, then f has to be the absolute minimum. Smallest point, right? It's always referring to the y values here. So it's not the x values going in, it's the y values going out. So it's the up and down of my graph. All right, values f of u, f of v are sometimes called absolute extrema, or the extrema values of f on that interval. Okay, so, identify absolute maximum and absolute minimum. So the absolute maximum would be the absolute highest point on this graph, which would be at, say u. So it's at u, and the value is f of u. So the point is at u, but the value is f of u. Okay, the absolute minimum here would be v, and the value would be f of v. Very good, right? Okay, so now, whenever we're checking these things, you have to always try to check the endpoints. But since we're only dealing with the graph right here, so bracket over my interval would be from A to B, okay, and then we would check those. So usually when you're just given a function, you're going to want to check the endpoints too. Definition, local extrema. Let f be a function defined on some interval I, and let u and v be numbers in that interval if there is an open interval in I containing u, so that f of u is greater than or equal to f of x for all x in the open interval. Now, what does open interval mean? Parentheses. Very good. So we were referring to bracket a second ago. Now we're referring to parentheses, right? So am I including the endpoints? No, I'm not including the endpoints. Okay? So f has a local maximum or relative maximum at u, and the number f of u is called a local maximum. Similarly, if there's an open interval in I containing v, so f of v is less than or equal to f of x for all of its x, it is a local minimum. Okay? Local extreme values. Okay, so now that is going to be like this graph right here. So a local maximum would be what? U1, right? Yeah. So it would be just a local maximum. So it is a maximum on the graph. Okay, it is a upper point, right? So it is going up here, but it's not the highest point. So this would be a local maximum of this function. Okay? I could say that the absolute maximum of this function would be at u2, right? So a local minimum would be V, and it would be at f of V, right? So there would be my local minimum, right? What would be my absolute minimum? It would be at one of the points, endpoints here, A or B, right? Okay, so it would be one of the endpoints. But now, would I include the endpoints here? Say no.
Yeah, no, because it's
No,
open.
no. This one right here is open interval, so it's going to be an interval of bracket A, comma, B, right? So that means I'm not including the endpoints. Identify absolute local extrema from the graph of the function. Find the domain. Determine where the function is continuous. Identify absolute maximum values, absolute minimum values if they exist. Find the domain. Identify any local extreme values. Okay, so it's the same thing. It's the same thing. So we're just gonna why? Oh, don't get all wonky on me. Why are you getting all cattywampus? All right. Yeah, I went there. I said cattywampus. All right, so this one right here. Now, what was the first question asked?
Domain.
Domain. The domain. Where am I starting? 0. So my domain would be from 0 to what?
3 pi halves.
Okay, so it's going to be from 0, 3 pi over 2, right? Okay, that's going to be my domain. Ooh. Yes. So, there we go. What was the next part? Is it continuous right there? Now, continuous means that is there any holes? Is there any jumps? Is there any gaps?
Nope.
No. Right? Nope. Okay, so it is continuous over the interval, right? So yes, it is continuous over the interval from 0 to 3 pi over 2. What was part C?
Identify the absolute.
Absolute. Now, absolute. So the absolute would be a bracket, right? Absolute was bracket. So what, can I include the endpoints?
Yes.
Yes, I can include the endpoints. So if I can include the endpoints, if I can include that, so what am I going to have here? So there's going to be maximum.
Yep. It's 0, 1.
Yeah, maximum at 0, 1, right? At 0, comma 1. Okay, minimum.
Yeah, pi common.
Okay, there we go.
And parentheses.
Yep. Because those are points there, right? Those are my points.
Yep.
Okay, what was the last one?
Find the domain and then identify any local extreme values.
Okay, so still same domain, right? Any local extrema.
There's a 3 pi halves.
Local extrema. Remember, local, that's parentheses, isn't it?
Yes, we can't.
Can you include the ends?
No.
No. Can't include the ends. So the local extrema, would there be any local extrema here?
No.
Yes. Is it including it? The local extrema just so happen to be
The absolute.
the absolute also, right?
Yes.
Is it include, so right here it is a parentheses 0, comma 3 pi over 2, right? Yeah? So the local for this one, because it's from here to here, the local just so happen to be the absolute in this case. Does that make sense? Because it's looking at this absolute and, so it's the absolute and the local. So this one right here, the local just so happen to be the absolute. On my previous problem, I had a local here, right? I had a local that just so happened to be the absolute on here. Okay, so this is, we identified only the local on this one. So this one was only a local, but this one is a local over the interval from here to here. Okay? We don't know end behavior, at the end. If I were to keep going on this, that would be a global off that. Make sense or no? Did I just confuse the crap out of everyone?
No, that makes sense.
So it just so happened to be, fit both criteria on this one. All right, so let's take a look at the next one then. All right, so I'm going to need your guys' help on this one. All right, so what was my first question I'm asking?
Find the domain.
Domain. So what's the domain going to be? Where am I starting at?
Negative 1 to 3.
-1, and I'm ending at
3.
I'm only looking at the x values, right?
Yeah.
Yeah. So it's -1 to 3, but now how am I going to close that in? Parentheses.
They're holes.
-1, 2, 3. Very good. Because those are holes there at the end, am I going to be able to do absolutes?
No.
I'm not going to be. Over that interval, I'm not going to be able to have an absolute value, absolute maximum or absolute minimum, right? Because if I'm not including the endpoints, I'm not going to get that. Does that make sense?
Yeah.
Okay, so now for this one right here, so what was the second part? What was question B?
Absolute values, but they don't exist. So.
Okay, we're not going to have any absolute off of this, right?
Yep.
Okay, so what was the next one after that?
Find local.
Local. So we're going to have some local, aren't we?
Yeah.
We have a local where?
Oops. Whatever.
Where's my max?
One, actually.
1, 0, 1?
Yes.
Where's my min?
2, -7.
Okay, right?
Oh, yeah, also we skipped over where it's continuous. Or it's where, is the function continuous?
Okay, it's continuous. So we said it's continuous where?
Well,
So it is continuous?
Yeah, on the open interval, -1 to 3.
Open interval from -1 to 3. So I don't have any weird holes, no jumps, no skips. Okay. Okay. All right, so let's try this again.
This is family friendly.
This is family friendly?
I'm sorry.
Ugh. All right, so on this one, what is my interval?
Open -1, close 4.
Open where?
-1 until 4.
And go to 4. Close. Okay. What was the second question?
Determine where the function is continuous.
Okay. So there's the domain. Is it continuous over that interval?
Yes.
What was part B? I thought we skipped B. B was supposed to be local or
No,
absolute.
I'm sorry. I got it backwards.
Okay,
that was
thank
my
you.
fault.
Okay,
really.
all right.
Last time.
Here,
Yeah.
have some sugar. Oh.
Thanks,
Okay.
You
dude.
give them sugar, you don't.
All right, need more sugar. All right, so, okay, what was B? What was question B again?
Determine where the function is continuous.
Okay, continuous. So there's the domain. Is it continuous there?
Yeah.
Okay. What's the next one after that then?
Find the absolute maximum or minimum if they exist.
Okay, so is this one going to exist?
Yeah, absolute minimum, nothing else.
Absolute minimum will,
But not max.
but not maximum, right? So we can have an absolute minimum because this is a closed here. So we have an absolute minimum there because I can include that value right there. Okay, that's good. What? So, but no absolute maximum, right? What is the absolute maximum here going to go up to? Infinity. Why?
It's asymptote.
Yeah, very good. It's approaching that asymptote. Okay, so now we got that. So we what else? What else came after that? We did our absolute. Now what's the locals? Okay. Okay, local would be Is there a local?
Couldn't it be form?
Do you know why it's not a local?
No.
Has its arms into a number.
Oh yeah, because we always have to do the open whenever.
Open, right?
Yeah.
Okay, local can't be an endpoint, can it? So there is no local on this one. So this one is no. All right. Does that make sense?
Yeah.
That was pretty good right there. All right, so now I gotta readjust this. So, oh, I'm probably gonna screw it up. Oh, I did, didn't I?
It's like you're hanging it back up on the wall. Oh, it's a little off. There we go.
Ha!
Something that
Let's call that a day. All right.
Close.
Close enough. All right. Okay. Yeah. All right.
Oh well. Oh no.
Oh, okay. Here's some more. All right. So, what about 13?
Yes.
Okay. What's the domain?
Open interval 0 to open interval E.
To E. Right.
Oh, it is E.
That is E. E's a number. So it's basically just E to the first, right? Which is 2.7 something.
Yes.
Yes.
Yeah, something like
yes.
that.
Something like that. Something like that. Okay. Is there any absolutes? No. Is it continuous over that interval?
No. Wait, yes.
Yes, it is continuous over that interval. Okay. There's no absolutes. Okay. So, what is going to be the local? Is there going to be a local here? No, because I can't include the endpoints, right? Okay, but it is continuous. That's how I can get from there. Okay, what about 14? What's my domain?
Bracket 0 to parenthesis 2.
Bracket 0.
Parenthesis, or comma 2. Right?
It's still all the way to the end of 6.
Oh, is it?
It's gonna be to 6.
Right, right.
Okay, because if you notice, it's approaching here,
And
right?
it picks right back up on it.
And it picks back up at 2. So
So
there
this-
is no
yeah.
gap. There is no gap. So in the interval says my domain is all numbers, right? In that. Okay, so now, what would be the next part? If it's what? Okay, is this going to be continuous? No.
I'm tired.
Okay, what type of discontinuity? Let's go back a little bit. What type of discontinuity? Jump. This is a jump discontinuity. Remember, so if you think about it as like a little man walking on this right here, and you're going from one piece to the other, he's got to jump. That's the way I think about it. All right, so yeah, it's like Mario Brothers. You have to hit run, then jump. Okay. Anyway. All right. Okay. So what was after that? So we have it. It is discontinuous where? At 2, right? So it is going to be continuous over the interval. It would be from 0 to 2 close union, right? And you would pick up bracket 2 comma 6. Oh, bracket. Right? Okay. What was the next question? Absolute. Okay. Absolute. Since over that interval right here, now, am I going to have a absolute on that first part? On that first part, is there an absolute there? We could have an absolute maximum, right?
0, 1.
Okay, but not over the entire interval, right? Just only for that piece. So it's really not going to be for the whole function. Since this function is going to be a piecewise, that's not going to work out. Okay, so now if I do this, let's do it from this side. Okay, over that interval, is there going to be a absolute? Yes, that's an absolute value or absolute maximum where? At 2, right? Okay. Absolute maximum at 2. What about absolute minimum? At what? At 6. So, okay. But in this thing, over that one interval, I could say yes. Okay, just for here and here. But would it be of that whole function? Yeah, it would be over the whole function. So my maximum would be here, my minimum would be here. Okay, what would be the next piece? What was the next question after that?
Locals.
Local. Do I have local? All right, yes, I do have a local, don't I? I have a local what? I have a local minimum, don't I? So since I have a local minimum where?
1, 0.
1, 0. So I have a local minimum here, right? So it's in my interval. I have a local minimum. It's not from the endpoints. All right? No? No minimum?
No.
Yes?
Not from the endpoint.
Okay, not from the endpoint. Thank you. Okay. All right, sorry. All right, and local maximum?
No.
Yeah, I would say that one would be at 2.
Right? Because it's not
Be-
the ends.
Yeah, it's not the ends. It's local. It's somewhere in between, right?
Mm-hmm.
So that one would be a local on that one. Okay? All right, so let's take a look at, I'm going to do this next one quick. All right, so is it discontinuous? Or even better, is it continuous? No, it's not continuous. There is a hole here, right?
Yeah.
Okay, so there is a hole there. All right, and so that means would there be any local minimum? Would there be a local minimum? No, why?
That hole.
There's a hole, right?
Yeah.
You can't have a minimum or a maximum at a hole, right?
Right.
So it doesn't exist there, so therefore it's not going to be a local minimum, right? Okay, what about local maximum?
No, those are ends.
They're ends,
Over the.
so this is no, right? Yep, so it's no. All right, so let's go on to the next one. All right, function is continuous, closed interval has to be absolute maximum and absolute minimum over that. Okay, right here, f has a local minimum maximum, then number c, then the derivative, f of c has to be equal 0, or f of c does not exist. Okay, differentiable takes local maximum or local minimum at c, then takes the derivative equals 0. Okay, so we have critical numbers here. Critical numbers. I have this point right here where it's going to be equal to 0, right? The slope is 0, and whatever that is. Okay, so I have two places here where the slope is going to be equal to 0. I have this point right here, which, can I take the derivative there? No. Why? Slopes are not the same on either side, right?
Yeah.
Yep, change the slope. Okay, so now both sides, it's going to be, so right here, this is a negative slope, and on that one's a positive slope, right? That's what you're saying? Say yeah.
Yeah.
Okay, good. That's what he said. All right, so now let's take a look. Any critical numbers here? Critical numbers from this. We're going to have, take what? What's the domain?
Everything, man. Yeah.
Is it everything?
Yeah, it's all real numbers.
Oh, real numbers. So now, yeah, I pull out the candy, and all of a sudden everyone starts like speaking up again. Okay, you're like, candy. All right. Okay, so now, all right. So let's see. So who wants some candy? Okay, that guy right there. Here you go. Okay, so now, what's the first thing I'm gonna do? What am I gonna write for my domain?
You're gonna write
Everything.
R, so it can be all the numbers. Or negative infinity to infinity.
Okay, or negative infinity to infinity, right? Okay, that's good. Now,
Let's take the derivative.
now take the derivative, right? Take the derivative, which is gonna be
3x squared. What's the number there? Yeah, minus 4x.
plus 9, right?
Yeah.
All right, so let's see. Next one. Okay, for this piece right here, I have to set that equal to 0, right? Go ahead, set it equal to 0, and who wants candy? Wow, no one wants to factor it that bad? Huh?
I'm doing it.
Factors to -9 and -3. You break it up.
Okay, so let's see. Can you factor out a 3 first?
Yes.
You want
Because why wouldn't you?
All right. And then, come on, I got candy to throw here. Come on now. Huh? More candy already?
Yeah, it's 1 and 3.
1 and 3, right,
Yeah.
James?
Huh? Oh. James doesn't know.
1 and 3, right? So it's going to be 3 and x. Is it both negatives?
Yeah.
Negative 1, x minus 3, right?
Yeah.
So when I set this equal to 0, I'm going to get x equals a positive 1 and x equals a positive 3. So now, what did I call those ones right there? Critical numbers, right? Those are my critical numbers. So that means those are the numbers in which that my derivative is equal to 0. When we set the derivative equal to 0, that means the slope there is 0, which is going to be like my graph right here. So I'm going to have my slopes equal to 0 here. So those are going to be criticals, right? Is there any place where it's going to be discontinuous or undefined? Say no.
Yeah, no.
No. Okay. So now I have those points there. So I got all the critical numbers, right? And over my interval, that's it. Is that easy?
Yeah. It's the easiest.
Okay, yeah, all right. So do you want to do, all right, we're going to do one more of these. Which one?
Let's do D.
D?
Yeah.
Yeah.
Yeah, trig. Everyone loves trig. Everyone loves trig. All right, so for this one right here, what is the interval for sine x?
0 to 2 pi.
What is it?
0 to 2 pi.
0 to 2 pi. So am I including, which one am I including here? Include 0, and it goes to 2 pi. Do I include 2 pi? No.
How come?
If you look at your unit circle, aren't they the same thing?
Yeah.
So the domain, since it goes back over and over, it's going to be on top of itself at 2 pi, usually. All right, so let's take a look. Since it does repeat, that's what I'm going to end up with. All right, so now my derivative, my g prime of x. G prime of x. What's the derivative going to be? Cosine x, set that equals 0. So over my interval, where is cosine equal to 0?
3 pi halves.
So you would be, it's going to look like this. So you would be like x equals arc sine or inverse cosine of 0. So where is cosine going to be equal to 0? And that's going to be when x is pi over 2 and 3 pi over 2? Yes?
Yeah.
Maybe? Did I lose anyone on that one? No, I have my unit circle and those are my top and bottom, right? So I get 0, 1, and over here I get 0, -1. Yes?
Yeah.
Okay. All right, so I got those right there. Crap. Okay. All right, so. No, this problem actually took a little bit too long. All right, so here's the steps. Yeah, you guys have it in your notes. Local is a open interval. A absolute is a closed interval. Okay, absolute, okay, crap. Okay, anyway, we'll finish this tomorrow because I really wanted to get to this problem. This is a good problem right here.
Oh boy.
No, it's a good problem. Anyway, all right, so.
Tomorrow we don't have to.
Oh yeah, I got you guys on Thursday. Yes, Thursday. All right, so I'm going to leave off the notes right here. Don't forget, like and subscribe.